This is Chemistry Made Simple YouTube channel. We are still looking at the basic concepts in organic chemistry. Today, the basic concept that we look at is none other than the methods that can be used to represent organic compounds. All organic compounds can generally be represented by using two general methods. And those two general methods are method number one, by using the molecular formula of the organic compound, which we shall see later in depth, and method number two, by using the structural formula of the organic compound, which we shall also see in depth later on. Now, first things first, what do we understand by molecular formula? The molecular formula is simply defined as the formula of a compound that shows the exact number of every element present in the compound. In other words, if you are able to identify the elements in a compound together with their corresponding exact numbers in the compound, then you will have been able to determine the molecular formula of the compounds. By basing on the general formula of alkanes, strictly aliphatic alkanes, the molecular formula of butane is as displayed besides here. Notice that butane has 4 carbon atoms, and therefore that becomes the value of N. By successfully substituting for N in the general formula of aliphatic alkanes, then the result is what is known as the molecular formula of butane. However, use of molecular formula as a method of representing organic compounds lacks exactness due to the fact that we may not be able to tell the actual bonding in the compound and also the position of the different groups in the compound. To illustrate this, did you know that the molecular formula of normal butane or straight chain butane is the same as the molecular formula of 2-methylpropane. So that is a challenge. Two different compounds but having the same molecular formula. Later on, we shall discuss such two compounds as isomers. But that is the challenge or the drawback of using molecular formula. The fact that it does not give exactness of the scientific information about a given compound. And this therefore takes us to the second method, which is structural formula. What do we mean by the word structural formula? A structural formula of a compound can simply be defined as the formula of a compound that shows the serial arrangement of elements in the compounds, the bonds in the compounds, and the exact location of the functional group in the compound. There will be 3 different structural formulae that can be used to represent organic compounds, and these are number 1, open structure formula, number 2, condensed structure formula, and number 3, bond line structure formula. Without wasting time, welcome to an open structure formula. An open structure formula is a structure formula that shows the serial arrangement of atoms in a compound together with their corresponding bonds. When we are writing the open structure formula of an organic compound, we must remember some facts. The fact being that carbon has a maximum valency of 4 and therefore must form 4 covalent bonds. That is one fact. And the other fact is that a single bond is represented by just a single line, a single straight line between elements, and a double bond is represented by two lines between two elements, while a triple bond will be represented by three lines between elements. As discussed in method number 1 above, displayed besides me is the open structure formula of butane. Now, using an open structure formula helps us to know the serial arrangement of the elements together with the bonds that are holding the elements in the compound. Second type of structure formula is the condensed structure formula. The condensed structure formula is the type of structure formula that shows only the serial arrangement of elements in the organic compound. Following from above, butane, as discussed above, has the condensed structure formula displayed there. Notice that there are no bonds because in a condensed structure formula, we do not represent the bonds between elements. And finally, bond line structure formula is the type of structure formula that represents the bonding between elements. A bond line structure formula is a series of straight lines normally drawn in a zigzag pattern, and it is always easy to convert a condensed structure formula, and for that case an open structure formula, into a bond line structure formula. Still using butane as discussed from above, then its corresponding bond line structure formula is as displayed. Is there any disadvantage in using structure formula? I mean open structure formula, condensed structure formula, and bond line structure formula as compared to molecular formula? Well, the answer is yes. And the only disadvantage that I see with my experience is that using structure formula to represent a compound is a little bit long and cumbersome. However, the advantage of using structure formula outweighs its disadvantage in the fact that it gives you all the ideas about the given compound. With practice, it is easy to convert a molecular formula into the corresponding structure formula. To illustrate this, we have an example here that we are going to discuss together. So, in this example, we are supposed to write down the molecular formula. We are supposed to write the molecular formula and then the open structure formula, then the condensed structure formula, and bond line formula of pentane 2O. So we start by writing our molecular formula. Remember that the general formula of the homologous series for alcohols is CnH2n. This is the general formula. Of alcohols. Why the general formula of alcohols? Because our compound pentane 2O belongs to alcohols. Now, from the name pentane, it means that N is equal to 5. And after obtaining 5 and successfully substituting it here, we get that, therefore, the molecular formula 5, substituting for n gives you 12, and then O. Please, these are obtained after substituting for n in the formula. That is our molecular formula, this one here. Now, by basing on our molecular formula, we can therefore now, this has already been obtained, we can therefore now write the open structure formula. Now, when you are writing the open structure formula, we always base on the name of the compound. That first and foremost is that we must have 5 carbon atoms. So this, like this, why 5? Because the name of the compound is pentane. So that means there are 5. Now, on each and every carbon atom, there must be 4 bonds, because carbon has a maximum valence of 4. So be careful. 1, 2, add 2 more. 1, 2, to make them 4. 1, 2, 1, 2, 1, 2. So we have already established that fact that since it is pentane, there are 5, it must have a 5 carbon chain. But specifically on position 2. So where do we find position 2? Depends on where you want to start from. The one who starts from this side, this will be position 2. And the one who starts from this side, this will be position 2. Ironically, both are correct. So if I start from this side, on position 2 is where we have the OH group or the hydroxyl group. Why? Because we are dealing with what? With alcohols. Alcohols, their functional group is OH. So that is why it is here. Now the remaining parts is that we have to fill in hydrogen, so this is the open. So now from our open structure formula, this one here, we can generate the condensed structure formula. How do we generate the condensed structure formula? Remember the definition of the condensed structure formula is that for it does not show the bonds, it just shows the series arrangement of the elements that are in the compound. So from this, we can have the first carbon is attached to 3 hydrogens. The second carbon has 1 hydrogen and our functional group. Third carbon, 2 hydrogens. Fourth carbon, 2 hydrogens. And the third. So this becomes the condensed formula. So still I'll have to encircle it, enclose it in red. Now from this condensed structure formula, we can get our bond line formula as follows. So this from here up to here indicates this and that one, and then this, and then that one. I am now in this position, this position, so from this we can therefore conclude that it is possible to convert each of the formulas into their a molecular formula into an open structure formula, and then the open structure formula into the condensed formula, and from the condensed formula to the bond line formula. At this point, I thank you very much for following what I've been presenting. If you have any challenge that is related to the learning, teaching, or any comment about my presentation, please send me an email by using the email in the description of this video. Once again, thank you very much for being part of this learning experience. Until next time, I remain yours truly, your chemistry teacher. Goodbye.